Hi, my name's Samantha Cheung, and I'm currently a second year PhD student studying at the University of Cambridge. I'm studying medicinal chemistry for cancer, and I'm interested in organic chemistry and being able to apply my chemistry knowledge to the huge efforts in trying to cure cancer. So there's a huge disillusion to what organic chemists do on a day-to-day basis. Now, a lot of people think that we play with Bunsen burners and that we do titrations, but in reality, this is rarely the case for either of these. I mean, we can't use Bunsen burners because a lot of the solvents that we use are highly flammable, so could you imagine the chaos that would be caused if we actually did this? Now, organic chemistry, broadly speaking, is anything to do with carbon, and it's quite unique really. It's got its own language and ways of explaining what molecules probably will react together and which ones probably won't. So it's our job as a synthetic chemist to take these ideas and put them into practice in the lab. So it's a bit like cooking really. You have all your ingredients and then you mix them together, add some seasoning, cook it for a little bit, and then you end up with your dish. Now, for chemists, we pretty much the same. We take our starting materials, we mix them together, perhaps we add some catalyst, but perhaps we heat it for a little bit, and then eventually, hopefully, you'll end up with a product that you want. Now you can now take this product and then react it further still, and eventually you can end up with quite a complex end product. Now things such as Taxol, which is one of the leading anti-cancer drugs of the moment, this is what people have done. So its first isolation was from Pacific yew tree, but whenever you isolate products from their natural source, you don't really get very much, and so it's not sustainable, and it can be quite damaging to the environment if you keep having to go back there to extract all these products. Now, so what synthetic chemists have done is gone about taking very simple starting materials and then being able to synthesize these highly complex natural products and to make it sustainable and being able to use it actually as a drug. So much of the medicines and drugs that you find in your kitchen cabinets and the ones that your GP prescribes to you, the ones that are used in clinical trials, we've had to get synthetic chemists to make these before they actually become batch produced. Now what do? I make molecules in the lab which I then go on to test for its anti-cancer properties against prostate cancer and to see what effects they have on the signalling pathway. So I hope you begin to see just how important organic chemistry is. And here's a little tip for you. Because of the fact that it is a bit like cooking, never trust a chemist who can't cook. Thanks very much.